Okay, welcome back. In this video, I am going to take you through how to run an independent samples t-test in SPSS and how to interpret your output. So the data I have pulled up is provided under the corresponding material on Blackboard. In this, it's just a silly example, so you'll just kind of have to bear with me, but it's a little bit fun. In this example, we have a situation that is appropriate for an independent samples t-test. So if I pull my chart, I can see that the independent samples t-test is used when we want to compare two groups on one outcome. All right, so clicking back to my SPSS data, I can see that I have a grouping variable here, gender. So I have some ones and some twos. And then I have one outcome that's called slurry. So let me click over on my variable view to get some more information. All right, I can tell here by checking out my values that male participants have been coded as 1 and female participants have been coded as 2. So I have males and females compared on number of times participants slurred speech in 1 hour. All right, so I can tell you the background to this silly scenario is the researcher took the participants out and took the 20 participants out and bought them 4 pints of beer. So each participant has had 4 pints of beer, and after which the researcher tracked the number of times they slurred, or he or she slurred his or her speech in a 1 hour time period following the drinking of the 4 pints. So the silly independent variable, or one of them, this probably a better term would be intervention, I guess, treatment, whatever, however you want to think of it, was giving the participants the 4 pints. Then we have our independent variable of gender being divided as either male or female. And then our outcome, or our dependent variable, is this assessment of number of times the participant slurred his or her speech in 1 hour. All right? So far, so good. Again, just kind of bear with me with this silly scenario. All right, so we're going to go back up to analyze, go back to compare means, and there is our independent samples t-test. All right, so we're going to click on it. If this confuses you, I think what would be easier is to think about your grouping variable first. Well, I know gender is my grouping variable, so I'm going to click that over here. That only leaves the other variable as my test variable, and it is. Now, you might already know that your test variable is that dependent variable and then your grouping variable. But if you forget, just think grouping variable first. All right, so once you've done that, you'll have to define your groups. And all that means is tell it that group 1 is defined as a 1 and group 2 is defined as a 2, if that's what it is. And so if this was your actual scenario, you might have your groups defined as 0 and 1, or 2 and 4, however you coded your groups over here. You just want to tell it that group 1 is a 1 and group 2 is a 2, or whatever, however you decided to do it. All right, I'm just going to click my options again. Same thing there. The defaults are fine. No bootstrapping. And then we're going to say OK. And it pops up our results for us. So just like before, we want to start by just examining our descriptive statistics. So the number of times they slurred speech in 1 hour, male and female, I have 10 of each. The male participants slurred 14 times on average, a little over 14, and the females slurred a little over 22 times on average. Standard deviations do differ. The males are a little less spread out in their counts than females. All right, now we're going to scroll here to our independent samples t-test results. All right, now remember, we are looking at the mean difference because our null hypothesis is saying there are no differences between males and females. All right, so just like before, I want to come down here and write it, except now I'll actually write it before we try to interpret it, which is what I should have done before. There you go. There's my pen. Let me click on here. Here we go. We should be good to go. Okay, so what I'm going to do is write my null. So my null hypothesis is that the mean of the population of, you could put a little m for males or a 1, minus the mean for females or a 2 is equal to 0. Right, so that's the null we're testing. The null says there are no differences between the males and females. My alternative could say that there are differences. I'm just going to do a non-directional, so males minus females isn't going to be 0. There will be some differences. And I'm going to set my alpha level before I check out my results at 0.05. All right, so let me go back to my findings, to my output, and see what I have. All right, let me explain these two rows. In the PowerPoint for independent samples t-test, I glanced over the fact that there are assumptions for this analysis. Assumptions are something we'll talk about in the next course. We don't try to tackle them in this course because there's so much other material to learn. So for now, we are going to only focus on this top row, okay? Speaking of assumptions, this Levene's test for equality of variances, that is the result of one of your assumptions. So we are going to just kind of mentally cross this information out and go right over here to our t-test for equality of means, because we are testing the mean difference. In this case, the mean difference is negative 7.8, and so thinking about my null, which says there are no differences, well, clearly there is a difference between males and females, but is it a statistically significant difference? Right, that's the question here. My t-value is negative 3.85. My degrees of freedom are 18. All right, so I'm going to click back over here and scroll down a little bit and just make a visual of what we're doing here. Now, we will get to the point where we don't do these visuals anymore, but for now, I want to just remind you what it is we're doing and sort of not doing. All right, so we have our 0 and our 1, 2, 3, negative 1, negative 2, negative 3. And remember, this is a t axis, and it also gives us the probability of obtaining whatever that t is, right? Okay, so in this case, my output tells me my t-value is here. Remember, I'm ignoring Levene's test. That's an F value anyway, but ignore that for now. The t is, let's say, negative 3.9. Let's round to that. Negative 3.9. And so I have negative. So 1, 2, 3. And then if I had a 4, that negative 3.9 would be right there, right? So t equals negative 3.9. And that corresponded to a p-value of 0.001. And again, I pulled that here from my output. Okay, negative 3.9, let's say, and a 0.001. So the probability of obtaining that test statistic, that negative 3.9, is 0.001. All right. Now, we have that information, and then we also have our alpha level, which is here. All right. So using my degrees of freedom equals, and remember, degrees of freedom is your group 1 plus your group 2 minus 2. So that's going to be 10 plus 10 minus 2. So our degrees of freedom equals 18. And if you forgot how to do this, it's on your SPSS output under, in that degrees of freedom section, okay? All right. I could go to my table in my textbook and figure out at 0.05, degrees of freedom 18, what exactly is that corresponding t-value. Without going to the table, I can look it up and tell you that it's somewhere, it's actually probably a little closer in because we have a small sample size. So I'll just put it right here around approximately 2. So this is my t critical that I don't know unless I go look it up, but that's okay. And then the corresponding p-value to that would be 0.05. So that's my p critical, if you want to think of it that way. So then the question becomes, is what I found, which is right here, is it further out in the tail than my critical values? And the answer is yes, right? Another way to think of that is to mentally compare your 0.001 to 0.05, all right? And kind of remember back in first grade when we made those comparisons. So we would say it is less than. If it is less than 0.05, we know that that means it's further out in the tail, that probability is even lower than our threshold. Therefore, we do have statistical significance. So this is a statistically significant result. Okay? And we can write out that finding like we might see in a journal article. And not knowing the research, we're using someone else's data. So we can't really say, okay, well, was that a desired finding, or was that really not what we wanted? Did we want the males and females to score approximately the same? We don't really know. Now, if this was our research and our data, we would absolutely know what direction we were hoping for, even if we had never stated it. Okay, and so we could say, and I'll kind of abbreviate as I write, so independent samples t-test results indicated a statistically significant finding. Okay, and we'll use our information that we know. We'll say our t with 18 degrees of freedom was equal to negative 3.9, which we know we can choose either one. I'm going to put the actual p-value, 0.00, that's a 1 right there. Okay, and that'd be it. That would be how we would report our findings. Okay, so again, we're getting a little quicker with this. We're moving a little faster, and so feel free to revisit these videos at any time to go back through it. The last thing I'll mention is on the output, we're going to get to the point where we take a look at the significance value, and you will know immediately whether or not that is statistically significant. With that, I want to point out to you how important these descriptive statistics become, because this statistically significant result simply says, what's the probability I would have gotten the mean difference I got if the null is true? Well, that probability was really tiny. In fact, it's so tiny that I'm going to declare that the null is probably not true, and I'm going to reject that null. And I can feel pretty confident saying there probably are differences in males and females performance on this measure. All right, but can you tell what it does not tell us? It does not tell us which group is doing what, does it? All it does is tell us what's the mean difference. It doesn't say who had the higher mean or who had the lower mean. In order to figure that out, we'd have to go back to our descriptive statistics. So this says, yeah, males and females are performing differently because it is statistically significant, but we'd have to look up here to our male and female means to know who had the higher score, who had the lower score, and same with standard deviation. Okay, so see what I mean? This gives us part of the information, but one reason we spent so much time looking at descriptive statistics this semester is because it's always going to be there. We are always going to need those descriptive statistics. Okay? That is it for independent samples t-test using SPSS.